In today's lesson, we are going to solve proportions. Yay! So the definition of a proportion is when you have two fractions that are equal. And you should all remember we've solved these before using cross products, because when you cross multiply, A times D should equal B times C. So before we actually solve any, I'm going to give you sets of fractions, and you have to decide if they are proportional or not using cross products. So here are three examples where we are just testing, are the two fractions proportional or not? And we're going to do this by cross multiplying. So on this first example, we're going to do 5 times 35, and 5 times 35 equals 175. And we're going to see, is it equal when you do 7 times 25? 7 times 25 is 175. So because both are equal, that means yes, those two fractions are proportional. So why don't you pause the video and try to figure out if the next two are proportional or not on your own. On the second one, when you cross multiply, you get 15 on one side and 14 on the other, and 15 does not equal 14, so those two fractions are not proportional. And on the last one, when you cross multiply, you get 48 on both sides, so that means it is proportional. The two fractions are proportional. So now we have a proportion where we're solving for the unknown, solving for the variable, and we solve by cross multiplying. So 6 times x is 6x, and it's going to be equal to 9 times 5, and 9 times 5 is 45. So to solve for x, we just have to divide both sides by 6, and then x equals 7.5. After you get your solution, you can check it by plugging it back in. 7.5 divided by 9, and see if it equals to the same thing as 5 divided by 6. You get the same decimal on both sides, so that checks that 7.5 is the correct answer. Okay, same idea. First we're going to do 3 times 30, which is 90, and then 8 times x, which is 8x. And then to solve, divide both sides by 8, and x equals 90 divided by 8 is 11.25. And then plug it back in for x to check the decimal. What is 3 divided by 8? And check the decimal. 11.25 divided by 30. You get the same decimal on both sides, so that checks that 11.25 is correct. Here's example number 3. This time it's a little bit more complicated because we have a variable on both sides, and within the fraction we have addition and subtraction. But we're still going to cross multiply. So we can do 7 times x plus 4, but that means that you're doing 7 times the quantity x plus 4. And then 5 times, it's equal to 5 times the quantity x minus 2. So they're in parentheses. So now we have an equation with the variable on both sides, and we have sets of parentheses, so we have to distribute. We have 7x plus 28 equals 5x minus 10. Get your variable onto one side. So since we have a positive 5x, we can subtract 5x on both sides. So we have 2x plus 28 on the left, and then a negative 10 left over on the right. And now subtract 28 on both sides. 2x equals negative 38, and then final step, divide both sides by 2. So x equals negative 19. And before we move on, go back and double check our answer. When you plug in negative 19, on the left we would have negative 19 plus 4 is negative 15 divided by 5. And on the right, negative 19 minus 2 is negative 21 divided by 7. And both of those you should get negative 3. So, it works. For this example, why don't you pause the video, write it down, and try to solve it on your own, and then come back and check your answer. Here's what you should have after you cross multiply and distribute. And now let's get our variable onto one side and finish solving. So you should get to this point where you have negative x equals negative 165. And remember, when you have a negative x, it means your last step is to divide by a negative 1. So x equals 165. And if you want on your own, you can plug it back in for your variables, and you can check to see if it works. So here we have a story problem, and you need to set up your information in a proportion and then solve the proportion. So let's read it. You're riding your bicycle, and it takes you 28 minutes to go 8 miles. So that's kind of a rate, 28 minutes to go 8 miles. So we're going to use that information to help set up our proportion. But then it also says, if you continue traveling at the same rate, how long will it take you to go 15 miles? So they're asking you how long will it take, which means they're asking you to solve for the time. So let's set up a proportion. There are multiple ways that you can set up this proportion and still get the same answer. I'm going to set it up as comparing minutes to miles. And really, if you wanted, you could write miles on top and minutes on the bottom, and it doesn't matter as long as you're consistent throughout the problem. So they give you a rate, 28 minutes in 8 miles. Or, if you write it this way, 8 miles in 28 minutes. So now use the other information and what we want to solve. This is going to be equal to, because we want to keep the same rate. We're solving for the time, and the miles, we have 15 miles. So you just have to make sure that everything matches up. So in the top problem, we have miles in the denominator, and that's consistent. Miles, miles. So over here, what we know about miles has to stay in the denominator. 15 miles. And then we're solving for how many minutes. But then down here, if we were consistent with our miles, miles are in the numerator, so that means our 15 miles would be on top and then time on the bottom. So it doesn't matter how you set it up as long as you're consistent throughout, and you'll get the same answer either way. So if we cross multiply, 8 times t is 8t equals 28 times 15 is 420. 20. And then if you divide both sides by 8, you should get that t equals 52.5. And that is 52.5 minutes to travel 15 miles if you keep the same rate as given. Here is a second story problem and our last question of the lesson. And same thing, set up a proportion and then solve it. An architect made a model building to scale so that 2 inches represents 40 feet. So we're comparing the model and then actual. So what are we comparing? A model and then the actual building. And they gave us a scale that on the model 2 inches is equal to 40 feet. Okay, so let's continue reading. If the height of the model is 3.5 inches, what is the height of the actual building? So they gave us the model and we're solving for actual. So let's be consistent. We have the model goes on the top, which is 3.5 inches, and then we're solving for the actual, which is how many feet. So we can now just cross multiply. So 2 times x equals 40 times 3.5, which is 140, and then divide by 2, so that x equals 70, and we're solving for actual dimensions, which are in feet. So if the scale represents 2 inches equals 40 feet, then that means 3.5 inches on the model would be 70 inches in actuality. So there is your lesson on proportions. Good luck, and let me know if you have any questions.